Okay, moving on to our example 4. So a cord is wrapped around a wheel initially at rest. If a force is applied to this cord, giving an acceleration a equal 4t, t is in seconds, determined as a function of time, a, the angular velocity of the wheel itself, and b, the angular position of the line OP in radians, in as a function of t lah. So one thing you need to notice is, of course, the acceleration, is it constant or not constant? It is not constant. Why? Because it changes with t. Right, and another thing is, you were given here is the acceleration, not angular acceleration. Don't be confused. One way to know it is you look at the unit lah. If it's angular acceleration, of course it will be in radian, right? Okay, so how do you find the angular velocity of the wheel? First, you need to find the angular acceleration. You have acceleration, you need to find angular acceleration. So how do you do that? You already know that acceleration is equal angular acceleration times the radius. So if the acceleration is 4t, is equal to angular acceleration times the radius, which is 0.2. So solving for angular acceleration, you should get 20t in radian per second square. So knowing this, you need to find the angular velocity of the wheel. So how do you do that? How do you get that from the angular velocity? Is by remembering that angular acceleration is equal to the rate of change of your angular velocity divided by time, right, by dt, which is 20t lah. So to find angular velocity, what do you need to do? You need to find the integrate. You need to integrate the angular acceleration. So you need to integrate 20t. So integrating 20t, so, and we also know it's starting from rest, right? So starting from rest, we integrate with until a certain velocity that we're interested in. The omega is equal to, is equal to integration of 20t dt, because you bring this dt over here, right? So find the integration between what to what? Between rest and between time is equal to 0 until a certain time that we're interested in, where you will have your angular velocity. So if you do this integration, what do you get? Here you will get your angular velocity is equal to, what is the integration of this? You will get 20t to the power of 2 divided by 2. Right, which is equal to 10t to the power of 2 radian per second. So this is your angular velocity. Next, you need to find the angular position, right, of this point P here. So from your angular velocity, how do you get the angular position? You integrate again. So this time, you know your angular velocity is equal to d theta over dt, and it is equal to 10 t to the power of 2. So rearranging, d theta equal tan t to the power of 2 dt, and then you find the integration. So starting from 0 until theta that we're interested in, from 0 second to a certain time t that we're interested in. So integrating for this, theta will be equal to tan t to the power of 3 divided by 3. So you will get 3.33 radian for the angular position. Don't forget your t to the power of 3. 3.33 t to the power of 3 radian.